Hello everyone, in this video we're going to be covering one-sided limits in continuity. Previously we evaluated limits for various functions, specifically two-sided limits, values the function approaches from both the left and the right. On the graph displayed, as we approach x equals 1 from the left, the function approaches 1. However, from the right, it approaches 2. Since these values differ, the two-sided limit at x equals 1 doesn't actually exist, but the one-sided limits still do. Using mathematical notation, we express this as the limit as x approaches 1 from the negative direction of f of x is 1, and the limit as x approaches 1 from the positive direction of f of x is 2. Alright, so now we're going to do an example calculating left and right-handed limits with the function on screen. To find the limits of piecewise functions as x approaches 0, we calculate the left-handed limit using the top function since we have to use values smaller than 0, and the right-handed limit using the bottom function since we have to use values larger than 0. Direct substitution gives us that the left-hand limit is 1, whereas the right-hand limit is 2. Note that since the left and right-hand limits differ, the two-sided limit at x equals 0 does not actually exist. By the way, here's a graph of the piecewise function, and as you can see, the right and left-hand limits do in fact equal 2 and 1 respectively. Now let's move on to continuity. We previously described a continuous function as the ones that you can draw in a single stroke without lifting your pencil, but as mathematicians, we want a more precise definition. So for a function to be continuous at point A, it must satisfy 3 conditions. 1. F of A is defined. 2. The limit as x approaches A of f of x exists. And 3. The limit as x approaches A of f of x is equal to f of A. Let's prove the continuity or discontinuity at x equals 2 for the function shown. Well, we find that f of 2 is defined, and the limit as x approaches 2 of f of x does exist. But the limit as x approaches 2 of f of x is not equal to f of 2. And since the third condition fails, the function is not continuous at x is equal to 2. Here are some practice problems to test your understanding. And here are the solutions. That's all for today. If you have any questions, feel free to email me at lowqualitymathematics@gmail.com. Let's do some more math in the next video. See ya!